Well, to keep it really short and sweet, right after World War II, the Japanese did not have a professional quality condenser microphone available that was comparable to, say, a Neumann U-47. And the Japanese radio network, NHK, started doing some prototype work on a microphone that would meet their needs, and they more or less copied a Neumann U-47, but it didn't quite work out for various reasons. And so NHK passed on building a condenser microphone, and then Sony picked it up. And so the work on the Sony C-37A would have started, say, in 1953, 1954, and the microphone became commercially available in Japan in 1955. And with the C-37A, a couple of things that stand out with the design of that mic would be, first of all, the microphone capsule. Instead of copying a Neumann capsule, Sony decided to design their own capsule from the ground up, and the Sony capsule gives you a choice of two patterns, and it's done acoustically. If you have a condenser microphone where the back plate is solid and the only exposure the diaphragm has to the outside air is on the front face of it, the microphone will respond to changes in the absolute air pressure, and it'll be omnidirectional. And then if you have holes that go through the back plate, if the holes are just the right size, you'll get just enough leakage of sound waves coming in the back to cancel sound waves coming from that direction. And RCA figured that out back in the 30s with their 77 D series ribbon mic and a couple of other RCA microphones. With those mics, they had an acoustic labyrinth behind the ribbon, and then there was a very precisely sized hole directly behind the ribbon to, again, let just enough air leak in to cancel sound pickup from the back. So the engineers at Sony were aware of what RCA had done, and they had adapted it to a condenser capsule. And I'm guessing it took a lot of slide rule twiddling and a pretty fair amount of trial and error to get the microphone capsule to work properly in both patterns. And then another quirky thing about the C-37 is that Sony had to deal with the conditions in early 1950s Japan. Electronic parts were not exactly readily available, and a serious issue that Sony dealt with was that they toyed with the idea of importing AC701 tubes from Germany, but the price was completely out of line, and so they decided, we're not going to use an esoteric German tube for a microphone. We'll use something that you can go to the local radio store and buy, namely a Type 6 AU6 tube. Okay, the 6AU6 was designed in the United States, and apparently during the American occupation of Japan after the war, the Japanese licensed the then standard American vacuum tube types from the American manufacturers, and so 6AU6s and the other usual suspects with American vacuum tubes were being made in Japan, and they were able to make very good ones. With the C-37, another thing that NHK was concerned about was that they were just getting off the ground with television broadcasting, and they needed a microphone that would be small enough that if it wasn't, or if it was present in the picture, the microphone would not upstage the performers. And that created a problem, because in order to make the microphone the size that NHK wanted it to be, the only thing you could have in the microphone was the microphone capsule, the tube, and maybe a couple of resistors and capacitors. You couldn't have a great big output transformer in the mic because the microphone would have grown to the point that it would have been the size of a U-47, and U-47s don't exactly look good in a picture. Having just the tube and the capsule in the microphone created a problem of its own, because if you had to have the output transformer in the microphone's power supply, the output from the microphone had to be at a relatively low impedance. So it was necessary to run the tube as a cathode follower, which a cathode follower is a tube circuit that has a gain of just under unity, but because of the gain being just under unity, the thing will be capable of extremely high headroom. And that's another thing that I can get into at another time. And so in 1955, the C-37A became available in Japan, and then a company called Superscope here in Los Angeles started importing them into the United States, and they became quite popular. And then, of course, with the C-37A, it was in production until about 1965, and in 1965, Sony developed a very early transistorized microphone, which was quite successful, and Sony has basically been building variants of that early transistorized microphone from that day to this. Basically, I wanted a microphone that had the idiosyncrasies of a C-37. The C-37 capsule, because of the way it's designed, it has a very well-behaved cardioid pattern. It doesn't. It has smoother off-axis response than many another cardioid microphone. And when you switch the thing to Omni, it behaves in a very predictable way, whereas with the multi-pattern European mics, the Omni pattern is kind of quirky, and the cardioid pattern is kind of quirky, and the figure of 8 pattern is kind of quirky. It's, those microphones are very good jacks of all trades, but they're not exactly a master at any. As I said, with a cathode follower, it has a gain of just under unity, and it's operating on a voltage of well over 100 volts. And with any reasonable load, the cathode follower can easily swing 15 or 20 volts without clipping the waveform. And in order for a condenser mic capsule to swing that kind of voltage, they would have to be getting subjected to a sound pressure level of, say, 150 dB/SPL. And it was kind of serendipitous with the C-37A, because when the engineers at Sony designed the mic, they weren't looking for extremely high headroom. They used the cathode follower for other reasons, namely to keep the microphone small, and then on top of that, since tubes were the only possibility, the microphone needed a high voltage to begin with, and in addition to that, the capsule polarization is basically stolen right from the cathode follower. With the C-37A, the cathode of the tube floats 150 volts above ground, and that becomes the polarizing voltage. And so with the voltages Sony ran, as I said, the headroom was way beyond anything that you'd ever need in practice, unless you were trying to record an atomic bomb blast at ground zero. And then another thing about the C-37A, with the earliest ones, Sony apparently was using an off-the-shelf line output transformer at microphone level, so there was no issue with the transformer being overloaded by the cathode follower. And the last word is that I took measurements on a C30 on the electronics in a C37A by simulating what a microphone capsule would be delivering, and using a standard signal generator that would produce like 15 volts output at audio frequencies. At any frequency down to 20 hertz, I could not get enough level out of the signal generator to produce any visible distortion on an oscilloscope at any frequency. With the C37A, it has a very distinctive sound quality, if you will. It has a more restrained high-frequency response than, say, the Neumann and AKG microphones, and so they don't tend to sound anywhere near as sibilant as, say, a Neumann U47 or U67 or an AKG C12. And if you are dealing with a vocalist who tends towards sibilance, that can really be helpful. With the MA-37, I opted to use an EF86 tube, which is a European audio pentode, which was developed in the 50s. And I chose it because several companies are currently manufacturing them. And I've used EF86s in the past in a number of applications, phonograph preamplifiers, microphone preamplifiers, and microphones. So I have many years' experience with that tube, and I knew going in that I could easily substitute it for a 6AU6. I have been building tube condenser mics that are adaptations of the Sony design for many years, and I've used both EF86s and 6AU6s very successfully, and I figured I'd rather deal with a tube that is still in demand for guitar amplifiers than risking having a tube become unavailable in the future. Well, as far as transformers are concerned, generally when I'm in the process of developing a microphone for the commercial market, I'll try several different transformers from several different suppliers, and I'll do careful measurements on the transformers to find out which transformers are unacceptable and which ones have potential, and then when I narrow it down to maybe 2 or 3 transformers, then it becomes time to do some beta testing. Now, one thing that's handy about a microphone with a cathode follower output is it's possible for me to take a stereo pair of microphones with cathode followers and feed them directly to the following preamp with no transformers in the signal path whatever on account of the low impedance. And then I can do A-B comparisons between the straight feed from the cathode follower versus the feed through the transformer, and I can tell whether or not the transformer is up to the job. And the transformer I opted for is a line output transformer made by Lundahl, and the Lundahl transformer has 2 primaries and 2 secondaries, and I have the primaries connected in series so I can get a choice of either a 1-to-1 ratio or a 2-to-1 ratio, depending on how I strap the secondaries. If you have the transformer strapped for a 1-to-1 ratio, the output level will be the same as what was coming off the cathode follower, and the impedance will be the same. Now, if the transformer is strapped for a 2-to-1 ratio, you'll get a 6 decibel loss in level, and the impedance will be a quarter of the impedance of the cathode follower. And now where that becomes important is you never know what a microphone is going to get plugged into, and some microphone preamplifiers have rather low resistive loads across their inputs. And if the input impedance of the following preamp is too low compared to the source impedance of the microphone, you can end up taking a pretty bad penalty with the headroom with the microphone. The electronics in the microphone simply can't swing the current that the following preamp is expecting to have swung across its input. So you end up clipping the waveform with the head amplifier. And a general rule of thumb is that you want to have, with modern equipment, the general rule is to have load impedances at least 5 times the source impedance. But unhappily, sometimes with the equipment that's available these days, in a worst case, you could end up with the source impedance and the load impedance being equal. And a lot of modern equipment will not put up with that at all gracefully. With the 2-to-1 ratio, I was covering my back end so that even with the worst possible combination of equipment, the microphone would meet its specification for headroom. With the 2-to-1 turns ratio that I originally designed for, the microphone would tolerate having a 700 ohm load across its output, and it would still give undistorted output at way over 140 dB SPL. And with many microphones, both tube and transistor, if you try that trick with say a 700 ohm resistor across the microphone's output, the electronics will clip at painfully low levels. Okay, now this is the power supply for the MA-37, and it is designed to deliver 140 volts DC to the microphone and 6 volts DC to the microphone. And as I mentioned, it has an output transformer inside the power supply. And then I provided the same, or essentially the same, base cut switching that was provided on the original Sony CP2 power supply. You'll notice that the switch here is marked M, V1, and V2. And the music position gives flat frequency response. The voice 1 position, the response is 3 decibels down at 100 hertz. And in the V2 position, the response is down 3 dB at 200 hertz. And so the voice positions are intended for close-up voice pickups, where a male voice in particular could well sound unnaturally bassy on account of proximity effect if you're using the microphone in its cardioid pattern. And then the voice 2 position is intended to give a somewhat more drastic bass attenuation. If kind of as a rule of thumb, I think the V1 position would be appropriate for female voices and higher pitched male voices, and the V2 position would be appropriate for particularly deep male voices, particularly close up. And both positions would be useful for suppressing traffic rumbles and such low frequency noises that have long plagued recording engineers.